Welcome to the next session of the MOOC course on Artificial Intelligence and Open Source Tools for Teaching Learning Excellence. In the previous session, we discussed about various pedagogical approaches. In this session, we'll talk about the pedagogical techniques which refer to the specific strategies, tools, and methods used to implement the pedagogical approaches in the classroom. They are practical, action oriented procedures that translate the theory into actual teaching practices. The pedagogical practices determine the learning experiences arranged for learners, thus directly influencing their learning outcomes. Dear friends, I am delighted to have you join us as we explore how effective pedagogy transforms the education from knowledge delivery to knowledge creation. Each strategy which we discuss today brings a unique dimension: the engagement, the reflection, the creativity, and critical thinking, all essentials for the 21st century learning. This session will take you on a journey through various teaching learning practices. Excellence is not about doing different things. It's about doing the things differently, with purpose and passion. As educators, we hold the power to ignite the curiosity, inspire the innovation, and nurture future ready learners. Let's begin with the first pedagogical technique, which is active learning. This approach emphasizes enhancing the learner's critical thinking skills by raising questions such as what they are learning and why they are learning, problem posing, and letting the students discover the answers. The learner acquire knowledge by investigation. Unlike the traditional lectures where students passively listen, active learning places students at the center of this process. They do something with the content, they analyze, discuss, apply, or create. Simple example if I take, in an electronics class, instead of explaining a circuit diagram, ask the student to design one that meets specific requirements. They will remember the concept far better. The second one is experiential learning. The next approach, when we say the experiential learning, it is learning by doing. And this is based on David Cobb's model, where knowledge results from the transformation of experience. The cycle goes from concrete experience, reflective observation, and abstract conceptualization, leading to active experimentation. By taking the students out of the classroom and into the real world environment, the fieldwork exposes them to the practical challenges and conditions the engineers face daily. It sharpens their problem solving abilities by requiring them to adapt to changing circumstances, navigate unanticipated challenges, and think critically under pressure. Again, to just cite a simple example, the civil engineering students, they conduct a site survey using drones. They reflect on accuracy and safety issues and then propose the design improvements, completing the cycle of experiential learning. The third in the row is the PBL. We call them the problem based or project based learning. This pedagogy of reflective practice and collaboration, wherein the students connect the concepts with the real life situations, so that it could promote lifelong learning and 21st century skills. While experiential learning gives real exposure, problem based learning focuses on solving open end problems, and project based learning extends this into larger multidisciplinary tasks. Unlike the traditional teaching, where the students learn theoretical concepts first, the PBL introduced problems upfront. Students then work collaboratively in groups to research, analyze, and propose solutions. Again, an example, a group of mechanical engineering students is challenged to design a, affordable prosthetic arm for children. They integrate the mechanism, the material science, and design thinking and learning concepts as they build that arm. So that gives you the idea what is problem based and what is the project based learning. The next in the sequence, dear friends, is flipped classroom. It is an innovative pedagogical approach based on the constructive school of thought. It is based on the blended form of learning with emphasis on 21st century skills such as creating, evaluating, and analyzing in the form of activity based learning in the classroom. Just take care. In the flipped classroom, we reverse the conventional model. The students learn the basics before coming to the class through pre recorded videos, readings, or online modules which are made available to him, and use the classroom type for application and discussion. So, in the flipped classroom, the learner explore basic contents before the class, and the class time is totally devoted to higher order tasks like analysis, debate, and application. Again, citing an example from the electrical engineering. In the electrical circuit course, a student watches a short animation on Ohm's law before the class. And in class, they design a real circuit, test it, and discuss variations with the peers. Next comes the collaborative and cooperative learning. Dear friends, collaborative is a key skill in engineering where most of the projects require teamwork. The team based learning encourages students to work together on complex tasks, fostering a collaborative environment that mimics real world engineering team. As the saying goes, excellence also thrives through collaboration. The learning together enhances understanding and develops essential life skills, teamwork, negotiation, empathy, and leadership. Again, taking an example, in a data analytics course, the team analyzes a common data set and presents a different visualization comparing the insights and methods. The teaching and enhanced learning is the next pedagogical technique in line. It is a pedagogy of learning with innovation and problem solving skills, where students are engaged using technology. The diverse need of the learners are catered to using digital and technological platforms such as Peer Deck for innovative digital learning. Friends, in this digital era, technology is not an add on, it is an enabler of excellence. The technology enhanced learning uses digital tools to improve assets, engagement, and outcomes. The technological advancements have enabled the use of simulation tools and the virtual reality in engineering education. These technologies provide immersive learning experience, allowing the students to explore complex engineering systems in a controlled and virtual environment. In this, we have various facilities, whether we have learning management systems like Moodle or Google Classrooms, we have MOOCs and platforms like Swim or NPTEL, which expands beyond the campus. We have AR and VR technologies making the abstract concepts tangible. Again, citing an example, in the virtual chemistry lab, the students can perform the experiments safely online before entering the real lab, saving times. So, dear friends, I wrap up by saying that these diverse strategies show that there is no single path to excellence. Effective teaching blends approaches using active participation, reflection, collaboration, and digital innovation. The real art lies in choosing the right method for the right learning outcome. To achieve excellence, we must learn, unlearn, and relearn. And the most effective teachers are reflective practitioners who grow with their students. Remember that excellence is not a destination but a journey of continuous learning, collaboration, and compassion. And if I say reflect on one teaching practice you will adopt this semester to make your classroom more engaging and impactful. Achieving excellence in education requires a dynamic and inclusive approach by teaching and learning. With this, I will stop here and have a refreshing learning. Thank you.